Hi, so welcome to new video, and today our topic is stress and its type. So which type of stress, what is stress, and how they define, and how we used to calculate in the during the CAD design of any product. So let's start. So what is stress? So in general, we can say whenever a force is applied on any object, internal resistance is developed inside the material, and this type of internal resistance per unit area on which area we applied is called stress. So like in the language we can say stress is the internal resistant force per unit area developed when the material is under the external force. So like what happened? Like this is one bar, and we can pull out. We apply the two pull out force in two opposite directions, and on the specify areas like these areas. So what happened when we pull it out the bar? The bar have some resistance, internal force which is produced due to the force applied from the external side. So for the finding the stress, we can use the stress which denoted by the sigma. The stress is equal to force by particular specific area on which we are applying. And what's the unit? So force unit is Newton, area is meter square for the SI units. We can also write Newton meter square is equal to megapascal. So there is a two main units in which we get the stress in any software or any type of data sets. So let's talk about the types of stress. How many types stress have, and what are the main things over there? So first of all, there is a three types: the normal stress, the shear stress, and the bearing stress. In the normal stress, there is also two subtypes, the tensile stress and the compressive stress. So let's talk about each and every stress type in detail. So for the normal stress, I told you is the two types, tensile and compressive. For the tensile, what is the tensile stress? Tensile, like what's the definition? Just I take the first for one example. There is the one road, or we can say this is circular shaft, in which we are applying force F in the two opposite and at the outer directions, not the inner, at the outer direction, like we are pull it out this one. So this type of uh, pulling force is considered as a tensile. So it's the tensile stress. The stress generate due to this type of force is the tensile stress. So tensile stress occurs when the material is subjected to pulling force, right? So like when the pulling force is applied is a tensile stress, and like what's the example of that? So stretching rod which I give you, the cable of the crane. So like the crane have the like this is the crane, and it's go from the here to here. So over crane, the also is attached over here. So there is a one force like this, and we apply like we connected something over here. So it's also gravitational force in this direction. So the two forces on the crane cable. Same the rope pulling a load. So like this is the rope and is the pulling the load. So it's have the same thing. Is the tensile stress inside the rope. So let's talk about the second one. What is the compressive stress? So compressive stress have the same thing but in the different direction. In the tensile, we pull it out the force, but in the compressive, the force is applying inside the surfaces like this. So like it's the pushing force. We are pushing the thing to compress it. Like what's the compress mean? The compress like for an example, if like there is the sponge ball in our hand, if we apply the force from the other direction, and after the applying the force, what happened? The size of the sponge ball will be decreased. So what happened? It's compressed. So there's the same thing with the products. So like it's the shaft, we are applying the force from the both side in the inner direction. So it have the compressive stress inside it. So what's the definition? Compressive stress occurs when the material is subjected to pushing force, causing it to shorten. So what it mean? Like because of compressive stress, when we remove the force, after then this shaft, the length of the shaft, it's over this is L, but over here is the L minus something delta L or what? Because like what happened? It's just the delta L because it's the length is changed. Like we compress this ball, so balls like the ball size is decreased. So same as it's same for the shaft. But what happened in the tensile? Like it's the length of the shaft will be increased for the tensile because we are pulling out. So if like we stretch the rubber, so what happened with the rubber? The length of the rubber will be increased. So same with the that. It's L, but the length for this one is the L plus delta L. So what is increased plus the regular length, right? So let's talk about the shear stress, the third and main type of the which is also applying the 50% of the products. It's all the things. So what's the shear stress? I we take the first example. There is the two plates, plate one, and there is the plate two, which have the rivet joint. So it's the bolt, and these two plate are attached with the bolt. So what happen if we apply on the top plate, the plate one force like this, and in the second one we apply the force like this. So what happened? Like this part have to go this side and the second part have to go this side. So in after then the shear stress is generated in the in the two surfaces in the opposite directions in the parallel cross sections. So like what happened with this the bolt? So like plate or like this or like over here like this. And the bolt will be broken after some time due to the stress and it like this. So what is that? Shear stress occurs when the force act and parallel, like they both are parallel to the cross-sectional areas. They both are parallel. In this, what happened? They are in the same axis. But in the shear stress, they both are the parallel. Like one is go is this and one is go in this direction. But both are the parallel. Like what happened? Like the best example is like we took the one paper, right? And just we try to from our left hand we apply the force in the right direction. From the right hand we apply the force in the left direction. So what happened? The page will be scratches. The like I example of the bolt and rivet joint I teach over here, and I explained the paper cut one. So third and the fourth and last type, what is the bearing stress? So bearing stress is generally apply when the like the there is the two parts which are joined together, and one part is applying force on the another part. Like for an example, the best example is a nut and bolt, nut and plate or nut and bolt. So like there is the one plate on which we apply, like with the screw, with the help of screw, we apply the bolt and we fit it. So what happen if this plate have to move, but the bolt is applying the force on it, so it cannot move. Like for an example, this is the plate, and we apply the bolt over here, and like if we apply the force over here, but it's fixed, so it cannot move, right? So what happened? The bolt is generated his own force to make the plate on the specific area which is uh dedicated to it. Like bolt is used for the and like bolt is used for to combine anything to at that specific place, not moving, right? To say the same thing. So same for the shaft on the bearing. So like there is the shaft, is the bearing over here. So what happened the bearing with the bearing? So like the bearing is the call as the also called as the cover. This is the inner part. So cover is always protect to the inner part. So bearings is always apply its own force to the shaft to just make it on that same place, not moving. So what happened? So bearing stress occurs at the contact surface area between the two bodies when the one is pressed against to each other. So like this applying to force over this and this to this. Like the shaft is applying force on the bearing and bearing is applying on the shaft. So due to that, the bearing stress is generating over there. And what's the equation for that? The load define the projected area, which is given. I have one small table which is helpful to for the MCQs as well as the just understanding the sums, numericals, or the force which like you can just see your product or the part on which the force is applied. So over here is the type of stresses, over here the direction of stress, over here is the just for the examples. So for the tensile stress, what happened? It's a pulling force like this. What's the example are? Cable and ropes. Compressive force. So for the compressive stress, we are applying force like this. And what's the example? Column, the building column, because in the building we have the like the earth surface and the top surface. So from the both, like the our weight is on the top surface, and the bottom surface, the earth force is already always go on there. And then the shear stress, so it's always look like parallel to each other and in the opposite directions. So riveted bolt joints. And the last one is the bearing stress, is for the contact areas, and I explain you how it's work. So it's the pin joints. So thank you for watching this video. Please subscribe to the video and be with